I heard you wanted to learn a little more about comparing volumes. So, if we call objects similar in geometry, that means that they're the same shape, otherwise known as proportional. That means that it's either an enlargement or a reduction of each other, the two shapes. You can also think about this like stretching or shrinking, but all the sides had to stretch or shrink the same amount. That's the same as we multiplied all the sides by one number, a constant. Let's pretend like this green block is 4 by 6 by 10, and this blue block is 2 by 3 by 5. How do we compare those sides? Well, each one is multiplied by 2. The width, 2, is multiplied by 2 to get 4 for this. The height, 3, multiplied by 2 to get 6, and the length, 5, multiplied by 2 to get 10. That's called a constant, and we can also call it a scale factor here, which will help us. How do we compare then the volumes of these? It's a little bit different than if we just compare length, say. So it would be easy to just multiply by 2 to get one line double to another line, but with volume we have 3 dimensions. So we have to think about each of those sides. Let's calculate the volume of this green block first. The volume would be 4 by 6 by 10, which is 240. And the volume of the blue block is 2 by 3 by 5, or 30. So we have 30 and 240 for the volumes. How do those volumes compare? Let's divide them. 240 divided by 30 equals 8. What's the significance of 8? Well, 8 is 2 times 2 times 2, or 2 cubed, the same thing. Why is that? We multiplied each dimension by 2, right? Length times width times height to get from the blue block to the green block. So that's the same as 2 cubed. It was just 2 times 2 times 2. So the volume of this is 8 times bigger than the volume of this. If we wanted to go the other way, we would just go, this is 8 times smaller than the green block. What about if we tripled the dimensions? That would be 6 by 9 by 15. So that would be each of these sides tripled to get this new block, let's say. 6 times 9 times 15 is 810. That's our new volume. Let's divide that by the blue volume to compare. 810 divided by 30 equals 27. What's the significance of 27? Well, that's the same as 3 times 3 times 3, or 3 cubed. Same thing. Why is that? Well, we tripled the dimensions of this block to get to the new block, and that was each side multiplied by 3. So again, 3 times 3 times 3. Why does that matter? We can find a pattern for any kind of similar figure, actually. So if we had quadrupled the dimensions to get an even bigger block, then it would be this scale factor. We would have changed the volume by 4 to the third power, 4 times 4 times 4, which equals 64. Or if we multiplied the dimensions by 5 to get a huge block, then it would be multiplied by a factor of 5 cubed, 5 times 5 times 5, and so on. You could do that for any similar figure, which is helpful. But what about if we don't have similar figures? What do we do now? Well, that means that if only 1 or 2 of the dimensions changed. So let's look at an example of these two cylinders. We have a red cylinder and a purple cylinder, and they have the same diameter of 4 centimeters, but they have different heights. The red cylinder is only half as tall as the purple one, 5 and 10. Well, that means that we have a scale factor of 2, because 10 divided by 5 is 2. Let's find the volume of each one so that we can compare. We know the volume of a cylinder is pi times the radius squared times the height. So for the red one, it would be 5 times 2 squared times pi, or about 63. And for the purple one, it would be 10 times 2 squared times pi, or about 126. When we compare the two volumes, we divide 126 by 63, which is 2. Why was it just 2? Because the height is doubled, so that was just one scale factor of 2. So to get from the red volume to the purple, it was multiplied by 2. That was the scale factor. Let's look at one more example to get an idea of if two dimensions changed. Here we have a yellow block and a red block. Let's pretend like the dimensions of the yellow one are 1 by 1 by 10. And the red block is 10 times 6 times 5. So the red block has a different width and length. Sorry, a different width and height. Let's figure out what our scale factors are. We multiplied the width and the height by 6 and 5. So those are our scale factors because the length stayed the same. So 6 and 5. If we just multiply those scale factors, we'll get the difference in volume. 6 times 5 is 30. And that means that to get from the yellow block to the red block, we should have to multiply by 30 to get the new volume. Let's check just to make sure though. So 1 by 1 by 10 equals 10. So that's the volume of the yellow block. And 6 times 5 times 10 equals 300. That's the volume of the red block. 300 divided by 10 equals 30, which is exactly what we predicted when we multiplied the scale factors. Just remember, all you need to do, multiply scale factors to get from a smaller volume to a bigger, or divide by those scale factors to get from a bigger volume to a smaller volume. And now you can compare volumes if one dimension or two or three change.